Welcome to AI in the Open, brought to you by Red Hat Open Source AI and Programs Office. This is an ongoing series that meets on the third Thursday of every month, bringing you home in the month in style, that deals with the latest and greatest research or work that is coming out of the Red Hat engineers or other Red Hat technical staff. Today we are, before we get going, just a reminder to everybody, this is being recorded and transcribed. So this is the wrong plane for you. Please deboard and find yourself another plane, but this will be recorded and transcribed. And with that, let's go ahead and kick it off. We're going to start with Hema and Taylor, and they're going to do from vibe checks to reality checks, scaling and improving AI evaluations. Evaluations are one of the most underused part of AI, yet the most critical parts of how because it's probabilistic, the parts of how it's used. They've asked if you could please save, well, you can't ask because you have to put it in chat. If you want to ask a question, please put it in chat, and they will take the questions at the end of the talk, the last 5 minutes, okay? So take it away, Taylor and Hema.
Awesome. Thank you, Stephen. Thank you for that great intro. Today we're going to be presenting on from vibe checks to reality checks, scaling and improving AI evaluations. My name is Taylor Agarwal, and I'm joined by my colleague, Hema Veeradhi, and we are software engineers in Red Hat's emerging technologies team within the office of the CTO. We have a packed agenda for this talk. First, we're going to give you an introduction to AI evaluations. Then we'll dive into why we need evals in the first place. Then we'll focus on app-specific evaluations. Finally, we'll broaden our scope and discuss benchmark evaluations, and then we'll end with some Q&A. So let's get started with an introduction to AI evaluations. So AI evaluations, or evals, is a term used to describe the scoring of an AI application's effectiveness. During AI evaluations, we collect a set of inputs and expectations. We take those inputs and we generate outputs with our AI application, and then we compare those outputs against our expectations to assess our application. It's essentially a testing framework for your AI application. They're a lot like traditional code tests. You can provide some input into your function, and then you assert that you get some specific output and some side effects. Likewise, AI evals involve putting input into your AI application, and then you assert that your application produces some specific response or has some side effects. The main difference is that AI outputs are non-deterministic, so some expectations may be met in different ways than we envision it. So while programmatic tests can address some of the evaluations we want to run, we will need other methods to address the more finicky situations. In practice, each of your measurements against expectations typically take one of three forms. The first is a programmatic type measure. Programmatic measures are pretty much identical to traditional code tests. After passing your agent your inputs, you use programmatic functions like regex or string matching to check your assertions. These can then be used to check things like proper ticket routing or running code tests for like code generation type agents or assessing tool calling accuracy. LLM as judge is another common method of measurement, and it handles the cases where programmatic checks just don't cut it. For these, you pass the agent response or its entire reasoning trace to an LLM along with a set of criteria and ask an LLM to grade it. With this, you can perform more qualitative checks on your application. For example, checking if it follows corporate tone or if a generated image adheres to some set content policies. While less common, a third bucket of measure that these type of evals can fall into is an environmental change. This is the case where success is not necessarily measured by the application's response or even its reasoning trace, but rather by its effect on the surrounding environment. So with these kind of checks, you can check for changes made to like your cloud infrastructure, like GPU nodes being spun up, or changes to your database systems, or other similar environmental changes made by your AI applications. AI evaluations can be further divided into two main types of tasks. You have benchmarks and app-specific evals. Benchmarks are your public, standardized evaluations for measuring the general performance of AI applications on common use cases. These typically are used to measure AI applications that are meant to be widely applicable, like coding harnesses or deep research agents or personal assistants. These would include the popular public data sets that you often see reported on model release pages, like SWE-bench or Terminal Bench or Tau Bench. On the other hand, app-specific evaluations are private, use case-focused evaluations for measuring the performance of AI applications on specific use cases. These evaluations typically involve your private data or environment, with inputs and expectations stemming from a specific internal scenario you want the application to solve. These would include like customer support cases, internal code review, or Q&A against your own internal knowledge base. So now that we know what we mean by AI evaluations, I'll pass it over to Hema to talk about why they matter.
Awesome. Thanks, Taylor. So we got a good understanding of what exactly AI evals are and their different types. So now let's look at their importance and their impact. So with AI systems being non-deterministic in nature, there is a stronger need for evaluations and measurements. And I'd like to think that these are the three main reasons why we need evaluations. Firstly, there is now a testing shift. Unlike traditional software testing, which relies on your predictable inputs giving you predictable outputs, since machine learning models and large language models are non-deterministic in nature, the same input can yield different results on different runs, hence requiring a comprehensive testing in place. Secondly, since AI systems comprise of multiple complex components that talk to each other, like you have a large language model, you have an agent which is talking to it, you also have external tools that the agent is interacting with and also maybe performing actions on your behalf. So without having proper guardrails in place, you can actually have your AI system run into various critical failures. For example, it can result in incorrect or hallucinated outputs. It can generate unsafe or harmful or even biased outputs depending upon what type of models you're using. And also it can violate certain format instructions. So I'm sure we've all had our fair share of experience of interacting with these models, and we can agree that they're not always the best at understanding straight away. So you need to further guide it and give it additional instructions in order for it to give you some safe outputs that you are confident with. And finally, just like how we are constantly evolving with technology and developing new products, similarly, evals can help optimize and improve the performance of your AI applications over time. With new models being released every other day, evals can help to compare, for example, frontier models versus some of the smaller open weight models. You can compare different model versions. You can compare different agents that are getting released every other year. So with the help of evaluation, having these frameworks and observability tools, we can systematically test the system's inputs and outputs. And having evals can help you to iterate further through the development cycles and also help you to validate your changes and your testings before you're releasing it into production. So now that we kind of understood the importance of evaluations, I want to switch gears a little bit and look at the importance of evals from a more business perspective. Now, evals are actually our engine for driving business ROI, return on investment. They're the only tool that we have at our disposal which let us mathematically prove if you can switch from a model to another smaller model that is 10 times cheaper. And they're the only tool that we can confidently help in releasing features faster without getting blocked by manual QA. So evals don't just find bugs, but they also help us save money and ship things faster. Hence, evals help drive three things: cost, quality, and speed. We all know that using frontier models like your GPT models or your Claude models for every single use case can get wildly expensive. But you cannot confidently switch to a cheaper, faster open weight models like the Llama models or the Quen models unless you have the evals to prove that the quality didn't significantly drop. So evals are the mechanism that can help a company slash its AI infrastructure costs safely and effectively. Evals also ensure that we are shipping a higher quality of product. For example, if you have an AI customer service bot that hallucinates a fake refund policy, then you lose money. If you have an AI search feature which gives you bad results, the user is most likely going to abandon the app. So evals help directly protect the user experience, and by continuously measuring things like accuracy, relevancy, quality, you're also directly impacting the customer retention and satisfaction, and in turn, you're shipping higher quality products. And having a uniform evaluation framework in place also enhances the developer velocity. Automated evals free up engineers to actually focus on building new features rather than manually QAing the old ones. And it also helps you get those features out the door faster, meaning that the business can recognize revenue from those features sooner, which is needed especially for this fast growing AI industry. So as Taylor mentioned, we can think about evals in two different ways. And now that we understand the strategic importance of evaluations, I want to focus on the app specific evaluations, which is more customized for your individual use case. So to do this and to manage all of our own internal AI applications within our team, we've leveraged a tool called MLflow. Now, MLflow has become the industry open source platform for managing your end-to-end machine learning as well as now GenAI lifecycle. It basically brings three main things which are important for any evaluation testing suite. It brings reproducibility to our processes. By automatically logging every single input and metric, we are ensuring that we are able to capture and replicate results and understand exactly how our application behaves. For example, when we're building an agent application, there are various traces that get captured, which log the entire LLM tool called span. It captures metadata like the number of input tokens used, the output tokens used, also giving you some cost analysis, and as well as all the entire reasoning steps that the agent took while performing its action. MLflow also provides a centralized hub, so every team can use a single shared MLflow instance to track multiple AI applications that the team manages. And this helps to move away from disjointed spreadsheets or local notebooks, giving your entire team a single source of truth for tracking all your experiments and also collaborating on improving these applications over time. And thirdly, it makes comparisons seamless. It has a built-in UI feature that allows you to also easily visualize and compare your performance metrics for different runs side by side, and also helping you to make data-driven decisions about which prompt or which model version or which agent is the best for our use case and which can be safely shipped into production. So now that we know what MLflow is, what does this actually look like in practice? We follow this four-step workflow that we have been using in order to leverage MLflow and evaluate our internal applications. The first step being defining our golden data sets. Instead of testing random prompts, we create a fixed high-quality set of inputs and expected outputs, which are specific to your use case. And we call these as the ground truth or the golden data sets. So every time we want to evaluate our application, we test it against these ground truth data sets and check if it's actually passing these data sets tests or not. Secondly, we also integrate ML flow tracing. And this basically acts like an X-ray for your AI applications. Think of it as all the logs that are getting generated by your application. So as the app is running, it automatically logs things like the user input, the model's final answer, and every other intermediate step that it takes along the way. And MLflow supports out-of-the-box tracing integrations for a large number of agent frameworks like LangChain, OpenAI, CrewAI, and a number of other frameworks. But it also supports OTel tracing. So you can even instrument your applications and collect telemetry data in a consistent way. So once you have all your data sets defined, you have your tracing in place, the third step is to actually run the evaluation suite. And here, instead of a human who's sitting and reading 100 outputs, MLflow can automatically score the responses against your defined metrics and set of rubrics, checking for things like accuracy, quality, and bias and hallucinations, and so on, depending upon what metrics you're defining for your specific use case. It also has features like LLM as a judge, which you can leverage for additional automatic scoring of responses. And also you have a human in the loop feedback mechanism where you can provide SME analysis on top of the responses given by the LLM so that you can further look at these and improve as we evaluate the application moving forward. And finally, the fourth step is that you can visualize all of this data through the built-in dashboard that MLflow has. You can compare your runs to your baseline, and you can confidently decide which version or which run gave you the most optimal results and is now ready for you to ship into production. And now I'll hand it to Taylor to talk about benchmarks.
Thanks, Hema. Now that we know what app-specific evaluations look like in practice, let's take a look at the other side of the coin, the more general side of the coin, benchmarks. So as mentioned earlier, benchmarking is used to evaluate agents more generally than app-specific evaluations. Here we have a few examples of popular benchmarks you'll often see on new model announcements. Terminal Bench is the most popular and well-regarded benchmark for measuring the performance of agents on coding tasks, specifically measuring an agent's ability to use the terminal to build features and even entire applications from scratch. It uses programmatic tests to verify the agent's outputs. Shell Bench is a newer benchmark that has been gaining popularity in the OpenClaw community. It measures the performance of agents as personal assistants, performing tasks like taking notes, keeping memories, managing files, and more. It uses LLM as a judge evaluations to measure the performance of agents on Shell Bench. Tau Bench and its variants measure agents in a customer service domain, asking them to help customers to book travel, handle banking transactions, and assist with retail purchases. Tau Bench is especially interesting because it performs all three kinds of evaluations. It has programmatic evals to check for tool calls with specific arguments. It has LLM as judge evals to ensure the agent reasoning passes some assertions. And it has environment evals to check that the database state was changed appropriately. Now, these are just a few of the thousands of benchmarks that exist in the wild. And this is part of what makes benchmarking agents so challenging. There's not a single common standard for running benchmarks. Each benchmark requires its own tooling to run and measure. It would require a significant amount of work to build pipelines that execute several benchmarks in sequence using their own tooling. Additionally, most of these custom tools don't support other harnesses, so you can't test the performance of a popular harness like OpenCode or a custom harness of your own design without picking apart the benchmark code. Lastly, benchmarking models that aren't provided by API providers often require unique configurations per benchmark, making it incredibly challenging to test the latest open source models. All these issues and more are what drove the development of a common standard for model and agent benchmarking called Harbor. Harbor standardizes the benchmark definition into three components: the environment, which defines the world the agent operates in, the instructions, which describes the task to the agent, and the verification, which assesses the agent's performance on the task. This all-encompassing standard allows you to run practically any benchmark you want with Harbor. Additionally, the tasks are all run in isolated sandboxes, meaning that you don't have to worry about your machine being compromised by a rogue agent or cross-contamination across tasks. Harbor is also incredibly modular. You can run any agent with any model on any benchmark. Even custom harnesses and self-hosted models work with Harbor. Harbor really solves all of the issues that we have with benchmark sprawl, and it provides a standardized modular toolkit to run any benchmark with any model and any harness. That's why we're using it to create our own leaderboard to compare the performance of agent harnesses with open models on popular benchmarks. In partnership with Red Hat's AI BU, we benchmarked the latest and greatest harnesses and models on several popular benchmarks, allowing viewers to quickly compare what models and harnesses would work best for them. For example, you can compare how Qwen 27B performs with OpenCode versus Claude Code, or you can see if Pi works better with Gemma or Nemotron. For all of our benchmarks, we report cost, token usage, time, and more metrics to help decision makers see the entire picture. We're also regularly adding new models, new harnesses, and new benchmarks to our leaderboard, so stay tuned and check it out. With that, we'll move over to Q&A, and we have some resources here for folks to check out.
Thank you, Hema and Taylor. That was great. I have recently been using MLflow with Goose. I've been adding some OTel output to Goose and been doing a bunch of work with that as well. It seems like the participants have been sending in questions through an alternate channel, not through the regular chat. So why don't I go ahead and ask some of the questions we've gotten so far. The first question that someone asked was, if a team is getting started with AI evaluations, what would you recommend they measure first, and how should that evaluation strategy evolve as they move closer to production?
Yeah. So depending upon their specific application or your use case, the number one thing that's often challenging for everybody to begin evaluations is those golden data sets that I was referring to. So it's always important to have some set of data in hand where we're already collecting certain inputs and outputs from our specific application. So for example, what are some typical questions that we're asking this application? What are the responses we're getting back? And also recording what are the expected responses that we think should be viable for it to actually say that this is a good output. So starting with that baseline golden data set, which represents a subset of what your ground truth looks like, is, I would say, the number one thing. And this is often the most challenging for a lot of teams because sometimes we don't know what the ground truth data set is. But the way that you can get started is to actually start having metrics and traces coming in and hooking your application to these observability logs and traces, so that once you have live interactions with your application, those can become your golden data sets over time. So you can actually check and see if these Q&A pairs or this set of input and output pairs that you're logging can define your golden data set. So that initial step takes a bit of work, but once you kind of have those golden data sets, you can start with basic metrics like things like accuracy, things like quality of the response. These are kind of out-of-the-box metrics that even MLflow supports. So you don't even have to calculate it, but it's rather already built in. And that would be one easy way to get started. And over time, as you get more familiar with it, you can define your own metrics, define your own rubrics, and have your own calculations, which are very much specific to your use case. So that's what I would recommend as a good start to think about evals.
That sounds great. That sounds great. Data is always the hardest part in this AI world. I don't think enough that the traditional engineers understand how important data is, right? Because it's not part of their traditional flow. So thank you very much. How about one last question? as AI systems become more capable and complex, what are the biggest pitfalls you see organizations falling into when they evaluate them, and how can teams avoid those traps?
Taylor, you want to take that one?
Yeah, I think probably the largest pitfall I've seen is waiting to do evaluations until well after the application is already in production. This can be challenging for a couple reasons. First would be the amount of time that it takes to instrument like tracing and evaluations on a deployed application. It can be somewhat challenging to put it into an existing application. MLflow makes that really easy. If you're already using like LangChain or Crew AI or one of the packages they already support. But if you're using something maybe custom made, it can be challenging to write up the code to send those traces to MLflow and record the information. So capturing traces early on in the development cycle is key. And then second, actually evals can actually inform whether you can go to production as well. As part of like the inner loop as you're developing your application, if you have a set of evaluations already prepared or a golden data set already prepared, you can be running that as you're making changes to your application before production and see, is this ready for production? Is the accuracy at a level that I'm comfortable with? Is the quality of response at a level that I'm comfortable with?
100%. Like, do it before you actually even start development, right? Because otherwise, how do you know what you're developing and what's happening? So thank you, Taylor and Hema, once again. That was a great talk. Yay, MLflow, yay, Harbor. We're gonna move on to our next speaker, which is Morgan Foster. And Morgan is going to talk to us today about emerging standards for sovereign GenAI workloads, which is hugely important all over the world. Sovereign AI is really a very hot topic and crucial to a lot, not only companies, but whole governments. So Morgan, why don't you go ahead and take it away?
Absolutely. Let me just share my screen real quick. That should do it. And can everybody see that?
You are good to go.
Perfect. So I will quickly introduce myself. I am, by the way, last talk was really great. Very, very polished and easy to follow with lots of useful information. Thank you for that. I am also on the emerging technologies team. And this talk was something that I had proposed at the very beginning of this year for PyTorch EU. And I focused on sovereign AI because the talk was in the EU, and I work on a standards committee for AI gateways in the Kubernetes community. AI gateways are part of what I'll talk about today because these are proxies that handle generative AI traffic in specific, and so they are an excellent point of control, and that makes them very useful in sovereign AI applications. So I was very interested in sharing that with the folks in the EU, and especially to raise some points about problems that I believe the EU had in the past achieving sovereign cloud infrastructure. So the talk was really made with that in mind. And in the last 8 months, things have certainly changed a lot. And we're very lucky in some ways because some regulations in the EU just came into effect this month and started to impact all of our experience of AI systems via the new watermarking that has been announced by various AI companies. That was directly in response to some of what we'll talk about today, which are the driving factors behind some of these standards, which are rules and regulations. So the first thing I wanted to point out is that there is not actually one definition of sovereign AI. There's no Webster's dictionary entry that you can look up for this per se. there is a why. There are goals that you can derive from that why. And the reason why it's hard to pin down an exact definition beyond that is that every country, every block of countries that wants to achieve a sovereign AI infrastructure will have different constraints that they work under and different strengths that they have to offer that will shape the implementation details. And so to get to those implementation details, first, I want to talk about the why by connecting it to problems we've had in the past as well, sort of for fun, but it's always nice to have a concrete example and a reminder that there's nothing new under the sun. And then we'll translate that into some high-level goals that I think anybody who wants to achieve AI sovereignty should be working under. And then we will look at India and the European Union as a couple of case studies, not a complete picture by any means, but a couple of case studies to see how folks are trying to achieve these goals. And there are slightly different approaches at play for the European Union and India. So first of all, why sovereign AI? Well, the shape of this why reminds me a lot of problems we were already encountering in the 80s. So in an earlier era of computing, the most sophisticated piece of software that you might expect to run in user space would be a compiler. These were quite the area of research, extending. I mean, there's still an area of research, okay, but they were much more at the frontier, the leading edge of computer science during this era from the 60s up through the 80s and 90s. And one of the things that was pointed out early on is that a compiler produces much more machine code than an individual programmer can hope to review. Prior to compilers being ubiquitous, if you wanted to write a piece of software that was performant, that could do interesting things, you generally had to write it in assembly. And this gave programmers a great deal of understanding about exactly what their code was doing. And so quite early on, there was a proposal by a gentleman named Ken Thompson in 1984 that pointed out that if you use compilers and they produce tons of machine code and you're no longer writing your machine code by hand, you have this problem where you can't verify that nothing bad is happening. And I think that should sound really familiar to us today. Essentially, somebody could produce a compiler that was tainted or an operating system that was tainted, and you could end up in a situation where you had perfectly clean source code that produced a binary with a subtle flaw that allowed a buffer overflow exploit for anybody who knew to look for it, or opened a socket for a reverse shell connection for some command and control. And this has remained a tension in our industry ever since, and it has driven a lot of the work we have done. Fundamentally, the way that you can most comprehensively approach this problem is by having a diversity of compilers available to you and deterministic builds. So we want builds that always produce when you compile your code, you want it to always produce the same bytes in the same order so that you can take a hash and then compare hashes over time. And if you have multiple compilers in multiple environments, then you can look for deviations. In the age of AI, we don't really have a great equivalent of that. The last talk was talking about some approaches we can use to approximate that by measuring the behavior of our systems, and of course measuring the way our system behaves under the influence of different sources of inference. How does Kimi K3 behave versus GPT 5.6 Soul or Opus 5. And so we have a lot of strong parallels, but our problem now, oh, and by the way, if you're curious about this, I was working in compilers 12 years ago at Mozilla. I worked on the JavaScript engine that is in Firefox, and I was working on just exactly this problem, and I still have my old prototypes if anybody's interested in those. But the thing about the problem we have with LLMs is that now we're more than one level removed from our machine code. We don't even write our own source code anymore, so it's even more difficult to search for subtle flaws that may have been introduced. And also, our organizations themselves are now running on this new kind of compiler, if you want to frame it that way, whereby if you think of an organization, a bureaucracy, as being a bit like an operating system, and maybe all of the emails and the spreadsheets and the presentations moving around between the folks employed by that organization or staffing that bureaucracy as processes, then you can imagine that the LLM that is helping to generate those emails and those spreadsheets and those presentations, you could imagine that if it were not well aligned with the goals of your bureaucracy in some way, that it could introduce, that it could manifest that misalignment in a way that is at least qualitatively similar to what we feared with our supply chain attack for compilers, our trust attack. So this is the why of sovereign AI, all spelled out. We have an economic imperative to use large language models, just like we had an economic imperative to use compilers, because if we don't adopt this technology, we will simply not output our work as quickly as everyone else, and that will collapse our comparative advantages in any domain. At the same time, these technologies produce more output than a human can oversee, whether it's machine code in the case of a compiler or natural language in the case of an LLM. And so we need to come up with systems to not just verify the outputs of these things in an automated way, though that is very important, but also to allow us to create environments where we can run these tools, where at least we have a certain amount of guarantees around the fact that we can verify a particular model, or we can verify a particular compiler, and then we can prove that it hasn't been tampered with. And that gives us some place to work from. And so a lot of the standards that we see evolving in response to this problem are all about solving exactly that problem, And so to make it even more clear, when you break the problem down across domains, what you can see is that we need access. So access to our capabilities that we cannot be economically or organizationally competitive without. We need to be able to have a diversity of inputs, just like with trust attacks, so that we can't have our access to critical infrastructure, a critical dependency in our infrastructure can't be suddenly snatched away from us or lost. Maybe an undersea cable is cut or a satellite goes down. You don't want to lose access to your source of inference. We need a control plane that stays reachable. This is something that I added in this talk or in the proposal early on, because the control plane is where I think a lot of a lot of engagements with sovereign AI really fall apart, because you can have all of your data in your territory and you can have all of the workloads running in your territory, and it doesn't matter at all if there is if one part of a key pair lives in a jurisdiction you don't control. You can lose access to the entire thing. That's something that the EU has learned the hard way. Privacy. So this doesn't have a direct parallel with the age of compilers, because we weren't typically shipping our source code across the internet to have it compiled. But in our current era, it's usual for us to ship our prompts to LLMs across the internet to receive back inference. And so privacy is very important in this era. So a lot of what we see with sovereign AI is about trying to guarantee that our inputs are not read by external parties. And then finally, control. Separate from control plane, we want to know that if we have some sort of system where we've deployed a number of agents, that they aren't able to chat with a model that we haven't approved, that folks aren't able to use a model that we haven't approved in sensitive circumstances, and that we know that whenever we think we're chatting with Opus 5, we aren't actually chatting with Kimi K3 instance that's been fine-tuned to always say it's Opus 5. How do we prove that we are communicating with the model we think we are communicating with? And then lastly, the one that's impacted all of us most recently is also, how can we control where the outputs from these models are used? So a real problem that countries face now is the fact that high quality text can be generated that can flood your legal system, that can flood your media ecosystem, not just text, but also images and videos in the context of a media ecosystem. And so there's a big push for, as part of sovereign AI, to be able to track the outputs of these models. So with that in mind, how are countries trying to achieve this? So the EU has an approach where they're not leaning on as many internal actors to achieve their goals. Instead, they're using their economic weight to write rules and financially incentivize outside parties to provide implementations and solutions to them. There is one area where the EU is investing heavily internally, and that would be in industrial AI. So they have Mistral, of course, in France, and a great deal of work has been done in the EU to support that company, and also to support training of AI models that are particularly well suited for industry. So not going after the frontier of capabilities across a broad spectrum, but really focusing on those industrial use cases, enterprise use cases, maybe physical AI use cases we may see. And so that's their access strategy in a nutshell. But then beyond that, of course, they enforce data co-location, GDPR style legislation, and this causes workloads to move closer to home because data can't cross over boundaries. But the problem that they've encountered is that when they try to implement controls, they often end up in a position where they have ended up in a position where their existing regulations have left control of access to their own systems that are running in their own territory up to outside parties. And so Most recently, if you go to the slides, there's links. Under oath, somebody from Microsoft was asked, a director for Microsoft, I believe it was asked if they could guarantee to France that no data held by a French public sector customer would ever pass in the United States. And that just wasn't possible because the command and control systems, regardless of the data collocation or even the workload collocation, the command and control systems that had been built would still sometimes pass over into the jurisdiction of the country where the companies providing it were hosted. And so that revealed a gap in the EU's approach. And so I would expect regulations to be their response to this, to try to close that gap. Beyond that, I'd say there was also a case recently where a person from the European Union lost access to their email account, and they felt very worried that maybe that had an international element to it because they had been involved in some international proceedings that might have ruffled the feathers of the country that hosted the company, that hosted their email. And so again, what they found in the EU is that their approach has this gap where the command and control centers are not well specified. Of course, open standards can help there tremendously. In India, they take a somewhat different approach. They have a lot of homegrown IT expertise in India, so I wonder if that might play some role here. India is also building infrastructure for training models, though I'm not aware of an effort to try to be best in class in a particular domain, save for supporting more of the languages that are not well represented in frontier models, and generally providing open weight models within the country. That really mirrors the EU in a lot of ways, minus that industrial focus. Similar to the EU, we have policies around data co-location, which force providers of cloud infrastructure and of inference to go ahead and build a sort of sovereign capability on behalf of the country, just so that they can do, just so they can do business there. But then a really interesting thing about India is they have a proposal for this unified intelligence interface, which is effectively a nationwide command and control system for access to models. And I found that very interesting because it stands somewhat in contrast philosophically to the EU approach in that way. And so that's something I found very interesting about India. And so when we break it down into layers, nobody controls chips. The United States and China themselves don't even control chip manufacturing. It's far too dependent on long supply chains. For cloud compute, we see across the spectrum, we see folks trying to build out compute infrastructure that can be used for training at some level internally. We even see that up in Canada and in other middle power countries. In terms of data co-location is emphasized, but like I mentioned before, it's really not enough. You can have your data sitting beside you, but not have the key required to unlock it. Models, we see a lot of emphasis on open weight models, but also an emphasis on homegrown small models. I'll say also in Japan, there is an emphasis, like in India, on models that are culturally and linguistically competent in a way that some of the frontier models might not be. I believe in Japan, the model that comes to mind would be Kotami from NEC, which is really focused on supporting Japanese speakers in a much more competent way than they are seeing from frontier models. On the control plane side, the EU is trying to continue, as far as I see, with a regulations first approach, while India is approaching this via infrastructure and protocols, which I find really interesting. Standards that exist today. So does the EU's approach work? I would say one example of it working is in this watermarking, the proliferation of watermarking schemes we're seeing. So Claude Code, Anthropic's models in general now, and OpenAI's, and anybody else who does business in the EU or in California, by the way, they need to provide some sort of way of attributing the output of generative AI systems back to their origin. And so right now, you might have a different endpoint for every generative AI system to say, did this output come from this source? That is not sustainable. It's a real problem. It's a problem in terms of reachability because that endpoint can go down. It's also a problem in terms of fan out. You're having to consume lots of network bandwidth and make lots of calls to try to check the provenance of any given piece of media. Well, we actually have an ISO that can already start solving this problem for us, not just for text, but across all pieces of media. And sure enough, interest in this ISO has upticked significantly. It allows local verification. And so what I would expect is that we will see this ISO or something derived from it becoming much more talked about in the near future, and something that we can then use to say, is this video real or not? Is this image real or not? And is this text written by a human or not, to some degree? It's still an ongoing process. That's why I would expect you to hear about it in the future. It is not yet ratified, but the need is very demonstrable right now. In terms of model identity, is this model who it says it is? Red Hat has a real stake here in the form of confidential computing. So the best we can do, and this also helps us to guarantee that our inputs are not seen by untrusted parties, by the way, is provide a secure computing environment that has hardware level attestation. That is, we know what the hardware is on this machine. We know it has not been tampered with. We have some sort of chain of provenance that tells us about who controls it. And then we can cryptographically verify that a workload is running in this secure computing environment. Once we have that guarantee, we can, within that environment, do something like make a hash of a model that has been loaded into memory. And then that hash can be compared with the known hash of an existing set of model weights. And then we can guarantee to ourselves, as we trust that chain of attestation, we can guarantee to ourselves that we're talking to Opus 5 and not to Kimi K3 pretending to be Opus 5. So if you're interested in that, I would look into SLSA, SigStore, and all of the work happening around supply chain attestation and confidential computing. There are lots of great articles from Red Hat. And then finally, I work, like I said, on a standards committee, building standards for AI gateways. Those are proxies that handle AI, generative AI traffic, that understand generative AI protocols. And what's happening there, I think, will be quite important in this space because it gives us a surface from which we can say things like, you are not allowed to use any of this model or this family of models in a way that doesn't depend on simply denying access to particular host names or IP ranges. And so what you can see here is we have a whole slate of open standards that can plug in at the proxy. So for workload identity, for knowing that a workload you're connected with, like I was just talking about, is who it says it is, we can use SPIFFE, which is a really excellent scheme for giving a cryptographically verifiable identity to some workload in a cluster or otherwise, and then it's something that can be federated. So you can take your trust domain that's implied by that, and you can join it with other trust domains. Anthropic supports SPIFFE now, so you can do something like give them the ability to attest to the validity of your workloads, and then your workload might get access to something like an MCP server without having to do any additional authentication, which is really nice. Obviously, telemetry is really important. This is another problem the EU has seen. You might have all of your workloads running locally, but all of your logs get touched by a system that is out of your jurisdiction. So we have evolving standards around generative AI telemetry, and we can enforce where those land at the gateway. Content credentials, similarly, is about understanding the validity of some, or the origin of some content that's been generated. Very important for generative AI. And then, of course, we have various attestation schemes that we can look at. Where are these things mature and not mature? Workload identity is quite mature. The origin of media content is not at all mature, though I would expect this, well, it's standardizing, but not mature, and I would expect it to mature very rapidly. I would be really interested to see if we might see the inverse case, where instead of just proving that content is generated by an AI, I would like to see this same scheme, and it's possible, to be used to prove that content came from a human. For example, you could use some sort of certificate that is put on your phone and considered tamper-proof to sign all of the photos that you make. And so that might be interesting. We have standards around building proxies that understand generative AI traffic that are forming, and those are quite early on. For example, every inference provider speaks its own wire protocol, and aside from MCP, we have other tool calling mechanisms which are not open standards. Communication between agents, we have the A2A protocol from Google, agent to agent, but that is not by any means ubiquitous. Right now, we have a very fragmented landscape in terms of the way we communicate with models and the way that workloads that depend on inference communicate with one another. And so the problem of trying to know how to parse all of those protocols so that you can write policies that enforce various things, as simple as what model am I allowed to chat with, because it's not just about the model you're running, it's about the model that's running the workload you're communicating with as well, is still very much an open question that depends on a lot of different standards committees. And then, of course, we have telemetry, which is the GenAI standards from OpenTelemetry are quite good. I don't know that they are at all ubiquitous right now, but those are still emerging. And finally, we have confidential computing, which is quite a mature area, but seeing it applied to inference is something that is still ongoing. We've set up inference infrastructure much more quickly than we have thought through all of the problems of providing secure attestation, to say the least. So to revisit, all countries have some stake in this, because they essentially don't want to lose access to frontier capabilities for any reason, whether it's access being revoked, lost because of a technical failure, or lost because their frontier capabilities have some security flaw that they've discovered. They want privacy for their inputs so that they can let their bureaucrats work with these systems without leaking state secrets. And they also want an ability to control the information that leaves these models and that goes into them, and which models can be communicated with in various contexts. So this is all very, very ongoing. I've included a lot of citations here for everything I talked about. If you're curious about digging in more to the problems in this domain that are being faced, any of the emerging standards that I mentioned, you can check out. And particularly, I would recommend that you check out what India and the European Union and Japan and Canada and these other countries are doing in this space, because really nobody has it figured out. And so I think there's a lot we can learn just by reading about the problems that they're having and seeing how they're trying to approach it. And that's it.
Thanks, Morgan. That was great. We're coming up a little bit close on time, but I really like your talk. I mean, I think one of the things Sovereign also really brings to the front is how important open source or open weights is to the, like, you can't really have it without, I mean, you can, but then you're reinventing proprietary in every single jurisdiction that wants to do it. So I just think it's really great. I have one quick question for you that we got. Do you expect sovereign AI to become a distinct architectural pattern, or will sovereignty requirements eventually become a standard part of virtually like every GenAI platform or deployment? Like, it's just like, this is part of what comes with the package.
I think that there will be distinct implementations. Like, I don't know that the EU is going to try to make the equivalent of a national AI gateway the way India has implied. However, I think that solving the problems that you need to solve in both cases will imply open standards, because whether or not you have a national AI gateway, you still need some way of enumerating all of the various protocols you may need to write policies for, so that you can understand those protocols. And so I would say that while one particular architecture is not something I would expect, what I would expect is a common suite of well-known protocols and a common suite of known pieces of infrastructure that are required for maintaining control.
Yeah, I mean, I could see that, like, and then those pieces of infrastructure, each individual country or implementer might want to tweak that in certain ways, given their requirements or their ideas about what the right solution would be for them. Yeah. Okay. Well, thanks, Morgan. That was great. We're going to go ahead and wrap up, everybody. Again, thanks to all three of our great speakers today. That was really informative. Somewhat tied together, but still just really great research or things to think about. Just a reminder, this is an ongoing series. So the next one will be the third Thursday in September. Stay tuned to the Luma channel or the Luma page, where we will list the speakers. That's where you can sign up. We'll put links in the show notes. This is going to be put up on the Red Hat Open YouTube channel. So if you search on Red Hat Open, you will find our YouTube channel. And these recordings, along with how to sign up for the Luma and everything else, will be there for the future. So thanks everyone for attending. And we look forward to seeing you at the next show. Bye, everybody.